cryptography. What is cryptography? It is the art and science of transforming a plain text into a encrypted format. Why do we need cryptography? Because we don't want a hacker or an intruder in between to know the information that two people are sharing with each other. For example, say I have sent a WhatsApp message to Karthik. No one in between should be able to understand it, should be able to get it. Even if they get it, even if they get my message that I have sent to Karthik, they shouldn't be able to understand what exactly is the message that I have sent. And I've also told you how to check this. For example, take WhatsApp. You go to WhatsApp wall, the beginning of WhatsApp wall of any person, you will see the chats and calls are end to end encrypted. It's clearly written there. It will be saying the chats and calls are end to end encrypted. No one, including WhatsApp, will also know what exactly is the message that you're sending to the other person. That is completely encrypted and sent. Before the information, for example, say I have typed hello. Before that hello is out of my mobile, that HELLO goes out of my mobile, it gets completely encrypted into an ununderstandable format. And I've shown you the complex encryption algorithms in the last class, like DES, data encryption standard, AES, advanced encryption standard. Even much better than that will be your asymmetric encryption standards like RSA algorithm. Right? So it gets completely converted into an ununderstandable format, and then it leaves your device, the device, sender's device. And then after receiving at the receiver side, after receiving, the receiver's device will decrypt it, convert back the encrypted text into the plain text that is understandable to the receiver. Right? That was cryptography. But cryptography is not enough. Cryptography is just converting text into into an ununderstandable format. When the data is traveling over a network, right, from a sender to a receiver, when this data is traveling over a network through the communication links, we have to provide security to that data. Encryption is not possible all the times, and we don't even want to encrypt data all the time. And we don't even want to rely only on encryption and decryption. What about the network? Network is also a place where security should be provided. Encryption and decryption are at the sender side and the receiver side. Sender and receiver is not enough. The data actually is going through some intermediate nodes in between. After it, the data is out of sender's device, it is in the network. It is in nobody's hand, and it should travel through series of intermediate devices and then should be reached by the receiver, received by the receiver. Then who exactly is supposed to worry about the security of the data in between the sender and the receiver? So network also needs to be secured. So that is our chapter today, network security. Right? Cryptography and network security come together as a subject. Of course, in some universities, cryptography itself is a subject in one semester. Network security itself is a subject in another semester. But for you, for us, in this regulation, we have CGNS together in one semester. Right. So what exactly is the network security service or security services? Network security can provide 5 services. This is our entire syllabus. This is our entire chapter. The 5 services that I have written there, this is what we are going to discuss in the next 1.5 hours today. Right? So network security can provide 5 services. 4 of these services are related to the message, the data that is being exchanged between the sender and the receiver, the message. 4 of them are with respect to the message. And the 5th service provides entity authentication. What is entity authentication? The person who is sending the data. 4 services are with respect to the data that is being sent and received between the sender and the receiver. 1 service, we will talk about the person who exactly is sending it, the entity. Right? So the 5 services include, I have written them as topics discussed in this section. The 5 services include message confidentiality, message integrity, message authentication, message non-repudiation, and finally, that is the last one is with respect to entity. First 4 with respect to message. Last one is entity authentication. Right? So these 5 we will be discussing today. Then what is message confidentiality? I'll go deeply into each one of them, a little bit deep into each one of them. But before I start the first one, let us just quickly understand what those 5 things are. So first 4 things with respect to message. The first one is message confidentiality. Confidentiality means privacy. What is privacy? No one except the intended person should know the data, should know the message, should understand it rather. Even if they get it, they should not understand it, right? So message confidentiality refers to the secrecy of the message. What is secrecy of the message? Only the sender and the receiver should know what that message is. They should, no one else should not get this message, or rather, even if they get the message, even if a hacker or an intruder tries to get the message in between, they should not be able to understand it. That is confidentiality. That's the first thing, first service that should be provided by the network. If somebody is not providing you this confidentiality, do you really think you will use that app and you will chat with your friends, boys with your girlfriends and girls with your boyfriends? Will you really do it? I don't really think you will do it, isn't it? Right? So message confidentiality is the first thing that a network is supposed to provide. Then the next thing, message integrity. Integrity is the word we have quite often come across. Then what exactly is integrity? Namakam. I've told you, it's belief. Belief in the message. Nammali, a message in nammali. Etla nammali mari. Right? A simple example to make you understand what message integrity is. Let us assume that there is a party in my house last night, good party. About 100 people have gathered in my house, and we are all celebrating. All that everything is going on over there. Everything is fine, perfect, picture perfect. Then suddenly after some time, my wife came to me and said that some stock is missing. We still need more. The party is not over yet, and the people who have come here, we don't have enough for them. We still need more. So I had to rush to the nearby supermarket to get some more missing items or finished items. Let us just assume. Now I have been to supermarket. I have just purchased whatever I felt is missing in the party. After procuring whatever I need, I just wanted to confirm with my wife that is there anything else that I can get apart from what you have told me when I was going out? Apart from what you have told me, is there anything else? So what I have did is, I have sent a message to my wife, WhatsApp message. Dear honey, do you need anything else? Done. So the message I have sent is received exactly the same by my wife, and she has replied back to me. She has replied back to me, no hubby, no, just ice. Some ice. She wants some ice. So she replied like this, no, just ice. This is the reply. Can you see it? Can you see it?
Yes, sir.
Yeah, yeah. So this is the reply text that my wife has sent back to me. Now what happened here is network has failed to provide integrity. Namakam. What happened to the message that is coming back to me? It was either encrypted and then decrypted. Whatever happened. The space between just and ice is gone. Even space is important. Even the blank is important, right? So the space, for some reason, during the transmission of the message to me, for some reason, the space is gone. Now, what happens if the space is gone? I would get a text message from my wife. No, just eyes would be like this. What would that become? No justice. What mistake did I do? She says, replying back me saying that there is no justice. What did I do? I've come out for you to bring the groceries that you need. But still you are replying me with a message like no justice. Here, it is not the mistake of my wife or the text that she has sent. The mistake is integrity of the message went missing. What is this? A space is gone. Just between just and ice, the space is gone and the entire meaning of the message is changed. So what is message integrity is whatever message the receiver receives should be exactly the same as if it was sent by the sender. There should not be a small change in the message. That is called message integrity. Message confidentiality is different. Message integrity is different. Confidentiality is making sure that it is private, privacy, providing privacy to the message. No matter whether space is missing or alphabet is missing or a number is missing or italics is missing, whatever it is, that is not the case in confidentiality. But whereas in integrity, that is the case. It's not about encryption decryption here. We're not talking about encryption or decryption. We're actually talking about the integrity of the message. Message should not get converted, tampered, changed at any cost. Exactly the same as the sender has sent it should be received by the receiver. That becomes message integrity. Done? Can I go ahead with the third one? Yep. Then comes message authentication, right? So confidentiality is providing privacy. Integrity is providing the trust on the message. Then third is providing the trust on the user. Message authentication means the authentic user has to send the message. For example, a simple example that Rishi has sent a message to Karthik. He used some spoofing technique or some technique. There are ample good number of techniques available on the internet. You can just search them and you can play with your friends if you want. So Rishi has sent a message to Karthik, but he has created that environment in such a way that the message received by Karthik, he sees that the message is not sent by Rishi, instead it is sent by me. The entity or the sender, actual sender is Rishi, but he makes something that it looks as if I have sent it. Or, or Rishi sends a message to Karthik showing that it is sent by me, simply speaking. This is authenticity is missing here. Who has sent it? Actually, Rishi has sent it. How can Karthik receive a message saying that Sandeep has sent it? That is a mistake of the network. Network should provide me that authenticity. Network should provide that authenticity to Karthik. Karthik should get that the message has come from Rishi only. How can it happen that I have sent it? That is authentic. Authentication, authenticity is the service that is supposed to be provided by the network. Third is message authenticity. Message should be coming from the person who claims to send it. Then comes message non-repudiation. Non-repudiation here refers to not accepting. So what non-repudiation means is, if for example, say, I have sent a message to Karthik. Again, Karthik is always the person who receives it. I have sent a message to Karthik. Non-repudiation is a kind of service where even if I deny later, in the due course of time, after some time, if I deny Karthik, if I talk to Karthik and say that Karthik, no, I haven't sent it. I am not the one who has sent it. Network should be able to provide me with that proof that I have sent it. I cannot deny that a message is not sent by me if I have sent it. I cannot deny that a message is sent by me if I have sent it. Who should take care of this? Network should take care of this. So that is non-repudiation. Cannot deny. A sender or a receiver should not be able to deny that they have sent or that they have received a message. Even receiving a message is also non-repudiation. A receiver received it, and then later the receiver should not be denying the fact that they have received it. That is another service provided by the network. So these four are with respect to message: confidentiality, the privacy of the message; integrity, the trust on the message; authenticity, authentication of the sender who has sent it; non-repudiation, not allowing a sender or receiver to deny the sent or received message is non-repudiation. Finally comes your entity authentication. This is with respect to entity. Now, entity here is the user who is using a device. Entity authentication is something like this. You want to see your result on SREC website or SRU website. You want to see your result. Can you directly check your result? Can you check anybody's result? There is a authentication procedure. You have to enter your user ID and password. I think it's your roll number and roll number again. I'm not sure exactly, but there should be something like that, right? So that is called entity authentication. So whom am I providing the data? There is data of every student in the database. The result of every student is saved in the database. But from the database, whose result is being viewed? You have entered some user ID and password. That particular entity's data is being fused, brought from the database, retrieved from the database and shown to you, right? So this is called entity authentication. Authenticating a user, authenticating a message is different. Authenticating a user is different. Remember this. Okay. So 5 services we are going to discuss today in this class. Let's go ahead now. So this is the overall picture. 5 services, security services with respect to message and with respect to entity. So security services for message are 4: confidentiality, integrity, authentication, and non-repudiation. Security services with respect to entity are only one, which is authentication. So let's start with the first one, message confidentiality. Manoj, can you log the meeting? Do you have the privilege to log the meeting?
Yes, sir.
Can you please log it? I think
Okay,
students are
sir.
still joining. Yeah, just log it. Right. So let's start with message confidentiality. This is already discussed by us in the last class itself. The cryptography is the technique to provide confidentiality to the message. Why? Because it converts a plain text into an ununderstandable format or into an encrypted format, which is not that easy for a user to decrypt it or understand it. Right? Right. Message confidentiality. The concept of how to achieve message confidentiality or privacy has not changed for thousands of years. It's the same thing. Even till today, it's the same thing. The message must be encrypted at the sender side and decrypted at the receiver side. That is a simple confidentiality technique. Encrypting the message at the sender side, decrypting the same message at the receiver side. This can be done by using 2 different procedures. You already know that in the last class. Symmetric key encryption or symmetric key cryptography and asymmetric key cryptography. So confidentiality with symmetric key cryptography. Both, what is symmetric key? Both sender and receiver will use the same key. Both sender and receiver will use the same key to encrypt as well as to decrypt. The key is shared between the sender and the receiver prior, before, and then they use it, right? Right, there it is, the diagram. We'll take 3 people in all my slides here. From now on, I'll take 3 people as example. Sender is always Alice, receiver is always Bob, and the intruder in between is always with the name Eve. I don't have that intruder here. We don't have the intruder name here. So the sender's name is always Alice, receiver is always Bob. The intruder or the hacker, the third person who can come in between, I gave the name as Eve. Eve, not me. Of course, the author also uses the same name in the textbook. Right. So in symmetric key, if Alice has to send the data to Bob, first a key has to be shared between them. The same key, secret key, is shared between Alice and Bob. Alice uses that shared secret key to encrypt the message that is being sent. Our device uses it. Then the data is converted, or the message is converted into cipher text, not cipher, or an encrypted data format. The encrypted data is sent over the network. Then at the receiving side, a decrypting algorithm converts back the ciphertext into plain text, and then the plain text is received by Bob, the receiver. Similarly, if Bob wants to send it to Alice, it's a vice versa. It's simply vice versa. Bob will use the same shared key, convert the plain text into CS, encrypted format, and it is sent over the network. At the receiver side, Bob uses decryption algorithm, converts the ciphertext back to a plain text, and then the plain text is read by Alice. Done. So this is simple symmetric key encryption and decryption to provide message confidentiality. Now the disadvantage with symmetric key cryptography is the disadvantage with symmetric key cryptography.
Shared key.
Shared
Key
key is
must
the
be shared.
yes, key must be shared first. If someone can steal the key, enough, everything is gone. Everything is gone. So then we went with asymmetric key cryptography, where we use a pair of keys, not a single key. A key is called as a public key and another key is called as private key. Public key is known to everybody. It is just given to the public entire world. Private key is retained by the person who created the public and private key pair and not shared to anyone. The messages can be encrypted with the public key of the receiver, and then those encrypted messages can only be decrypted by the private key of the receiver, which is not shared to anyone. So only that person can decrypt it. That's the biggest advantage of asymmetric key cryptography. So here it is, message confidentiality by using asymmetric keys, not similar keys, two different keys, public key and private key. Let us assume Alice wants to send data to Bob. Alice uses Bob's public key. That is the difference. So if a sender is sending data, the sender encrypts. At the sending side, the encryption happens by using the public key of the receiver. Private key of the receiver is not shared to anybody. So now Alice uses, can you see there, Bob's keys? There are two lines coming, one line and two arrow marks coming out of it. So Alice uses Bob's public key. Pink key is always public key. Bob's public key to encrypt the data, and then the encrypted data is sent over the network. Even if anybody receives the data without the private key, they cannot decrypt it, and the private key is possessed only by Bob. So Bob receives the data, uses his own private key to decrypt the data and gets the plain text. Similarly, if Bob wants to send data from this side, now Bob has to use Alice's public key to encrypt the data, send it over the network. Alice will use his own private key to decrypt the data. This is the difference between your symmetric key cryptographic technique and an asymmetric key cryptographic technique. Single key and a pair of keys. Done. This is all discussed in the last class. Extensively we have discussed in the last class. So that's about message confidentiality. Very simple. Lot of algorithms are there for message confidentiality. Hope you remember those algorithms that we have discussed. Simple, starting from simple substitution algorithms, transposition algorithms. We started with a very simple, plain algorithm. We went to such an extent of algorithm where the encryption standard has grown to an extent that it is very hard to break or hack the message in between, right? So those were a lot of techniques that we have discussed. So if somebody asks you a question to write about algorithms on message confidentiality, you have to write the last class, encryption and decryption techniques. Don't have to write all of them, but you can start the basic algorithms first, and you can just give an example of DES. Don't draw the diagrams and all. You can just tell what DES will do, what AES will do, what RSA algorithm will do. Okay? Right. So that's about message confidentiality. Let's move to the next second service provided by the network on message, called message integrity. So what is the difference between confidentiality and integrity? Confidentiality refers to privacy. Privacy, that nobody else can read the text or understand the text. But whereas integrity refers to the message trust itself, which means message should not get changed, tampered. It's not about encrypting, decrypting. I don't care about encryption or decryption here. I'm talking about the message should not get changed, tampered, or altered. That service is called message integrity. So I have written there the first line itself. Encryption and decryption provide secrecy or confidentiality, but they do not guarantee integrity. Integrity is a different thing. Confidentiality is a different thing. Integrity is a different thing. However, on occasion, we may not even need secrecy, but we need integrity. Do I need secrecy here? My wife has sent me a message. She is my wife. She can send me any message. I don't really need secrecy here. What is missing here? Integrity. That was most important for me here. This is not correct, right? So confidentiality is not needed here. We both actually needed integrity in this message, not confidentiality of the message, right? So on occasions, we may not really need confidentiality, privacy. We need integrity. And now we will talk about how message integrity is provided by the network or by some algorithms, by using some algorithms, right? So I have a few topics I have written there. I'll use a document and a fingerprint. The message that I'm sending, we'll just consider it as a document. Any message that is being sent and received, we instead of calling it as a text, we call it as a document that is being sent and received. Document and fingerprint is what first I'll discuss. Message and message digest will be the second thing. Creating and checking the digest, message digest. Second point, message digest ఉంది కదా, how to create it and how to check the digest is the third thing. Then we will use a hash function and we will use a hashing algorithm, specific hashing algorithm called SHA, secure hash algorithm. SHA-1 is a version of SHA, secure hash algorithm. This is what these 5 things are. Very simple things, don't worry. SHA is a complex algorithm, but I'll not explain you how it works. Don't worry. We'll just understand what it is. That's it. So 5 things we are going to discuss with respect to message integrity. So how exactly it is provided? To preserve the integrity of a document, of a message or a document, both document is needed and a fingerprint is needed, right? I'll now go back to second unit, data link layer. Data link layer. What was the functionality of a data link layer that we discussed more about in the beginning of data link layer? What was the functionality? Can someone tell me?
Node to node.
Node to node delivery, right? If node to node delivery, if something goes wrong, what was the next responsibility of data link layer?
Error control and flow control.
Error control and flow control. Excellent. We wanted error control and flow control was the next. After node to node delivery, the next thing we wanted was error control. Now, in error control, though it could be a technique like parity, simple parity, 2D parity, it could be checksum, it could be cyclic redundancy check. There is one commonality in all those techniques. What was it? One commonality in all those techniques.
Adding,
yes, adding redundant bits. Excellent.
Parity bits.
Parity, adding parity bits. Two-dimensional parity, adding additional parity row itself. If you go to checksum, we added CRC bits. If you go to if you go to CRC, we added CRC bits. If you go to checksum, we added checksum. If you go to Hamming code, even in Hamming code, we added redundant bits in between the data. So what was the commonality there? To the original message, we always added additional bits. What was the role of those additional bits? To make sure the message is error-free, to check, not to make sure, to check whether the message at the receiver side is error-free or not. Don't you think that is integrity? Don't you think that is integrity? Integrity and ఏంటి మరి అదే కదా, making sure the receiver receives the exact data. How? You have provided some algorithms, error control algorithms. Those algorithms have helped you to check whether there is an error in the message or not. If there is an error, the message was discarded. It was not received. So if I had message integrity technique provided to me, my cell phone, when it has received this message, it should be able to check. It should be able to check whether this was the message that was sent by my wife or not. Compare, make a comparison, then decide whether this should be displayed to me or not. If it could identify that no justice is wrong, it was no justice for whatever reason, whatever it is, అసలు విషయం తెలిసినా తెలియకపోయినా ఇది కాదు అని అర్థమైతే చాలు రిసీవర్కి. What was the actual data? A receiver need not, if receiver need it, it is all gone, right? It's all finished. I should receive it. So even if the receiver doesn't know what the actual data is, it should be able to identify whether this is the correct data sent or not. If the answer is yes, this should be displayed to me. If the answer is no, this should be discarded and a request should be put back again to resend the data. Right? So here, if this is the document, no justice is the document that has come. Fingerprint is that additional data that is added to it. Just like in data link layer, you have added redundant bits. The actual data is document. The redundant bits are fingerprint. Similarly here, the actual data that is sent by the sender will be the document. We will use an algorithm to generate additional data. Whatever it is, we'll generate additional data. We call that additional data as fingerprint of the message. Fingerprint is used to identify, right, whether that message is correct or not. నా fingerprint దేనికి యూజ్ చేస్తాం? నేనేనా కాదా అని చెక్ చేయడానికి. Similarly, fingerprint of the message is used to identify whether that message is the correct message that has been sent or not. Then we put message and fingerprint together. The document and the fingerprint is put together as sent. So not encrypted message is sent. Encrypted before encryption or after encryption, I don't know exactly. We will see as we go on. Either before encryption or after encryption, what will happen? It is put to some algorithm. What algorithm? Message integrity algorithms. What will they do? They will generate a fingerprint for this message. After generating a fingerprint, message is added with the fingerprint and all of that is sent to the receiver. Now the receiver will also perform the same thing. If after encryption ఈ అల్గరిథం యూజ్ చేస్తుంటే అక్కడ బిఫోర్ డీక్రిప్షన్ ఈ అల్గరిథం యూజ్ చేస్తారు. బిఫోర్ ఎన్క్రిప్షన్ ఇంటిగ్రిటీ అల్గరిథమ్స్ యూజ్ చేస్తే ఆఫ్టర్ డీక్రిప్షన్ ఇంటిగ్రిటీ అల్గరిథమ్స్ యూజ్ చేస్తారు. టు చెక్ వెదర్ ది మెసేజ్ ఈస్ రిసీవ్డ్ పర్ఫెక్ట్ ఇంటాక్ట్ ఆర్ నాట్. సింపుల్, రైట్? సో దట్ ఈస్ ది టెక్నిక్. ఓవరాల్ ఎన్ని అల్గరిథమ్స్ చెప్పినా ఏం చెప్పినా సరే ఒక్కటే సింపుల్ ప్రొసీజర్. Take the document, put it to a procedure or an algorithm. It generates a redundant data, additional data, that is called as fingerprint. Now the actual data and the fingerprint are sent together to the receiver. Now the receiver will again perform the same thing and check whether the data is perfect or not. I'll show you with diagram, don't worry. So the best technique even till today we know from your data structures is hashing. Hashing is the best technique that we know, right? So now how this fingerprint is generated? The document is taken, the message is taken, message is put to a hash function. Hash function will generate a hash value. This is called as message digest. Remember the word from now on till the end of my last slide, till all the slides are finished. Whenever you put a message to a hash function, the generated hashed value is called as digest, message digest. So this message digest is called as fingerprint. Actual message is called as document. The message digest generated is called as fingerprint, right? Now, can someone from the class tell me why hashing? Why always hashing is used in such techniques? Not only here, even in OS we have come across hashing. Even in database management systems we have come across hashing. Again, when I come to network security, I'm talking about hashing again. What is that best feature of hash technique that makes it so popular, so good to use? Anyone?
Encryption and security.
Encryption is okay. Encryption and security.
Encryption is done, but decryption is not done.
Excellent, sir. Yes, encryption is done. I do accept with that. Security is there, but no decryption. Hash function is always one-sided. We call it unidirectional. Encryption and decryption are different. See, encryption and decryption are together. Actually, take a plain text, encrypt it. The encryption algorithm is always in such a way that it can be that ciphertext or the converted text can be converted back or decrypted back to the plain text. But hash function is not like that. You take a text, apply hash function on it. The output you get, somebody sent a message in chat box. Maybe they said the responsibility of hashing, the goodness or greatness of hashing. Okay. So the hash function is in such a way that you take a message, apply the hash function on this message, and create a message digest, a hash value. It is only unidirectional. Now, if I take this hashed value, the message digest, and apply inverse hashing, there is no inverse hashing at all. Apply inverse hashing on it, I cannot recreate the original message. So that's the best part. Message confidentiality is both ways. Encryption can happen and decryption can happen. When I'm talking about message integrity, I'm not even talking about reversing. We only have to put it to a unidirectional algorithm. That's enough. Enta happy delta decryption undadu ikkada. So the complex of the algorithm is reduced or increased? The complexity reduced. Generally, if I say there is no decryption, the complexity is reduced is the term. Even I would say the same answer. But reverse cheyadaniki avasaram leni algorithm use cheyamante etlanti algorithms use cheyochu? ఇంకా మన ఇష్టమేగా. If we don't want to reverse it back, the kind of functions that you apply on the message, మీ ఇష్టం. You can put the complex mathematical equations that are possible on that message and simply convert it into into a hash value or a message digest value. ఎందుకంటే రివర్స్ తీసుకోవాల్సిన అవసరం లేదు కదా. So that's the difference. So when you are encrypting it, you should be so cautious. The algorithm should be so cautiously designed that every step that is encrypted should also get decrypted. But the algorithm here in hashing, you don't even have to worry about de-hashing it or inverse hashing it. One direction, right? So that's the difference here, right? So this is how a fingerprint is created. Message digest is created. A document put to a hash function generates a value. That value is called as message digest. Here we call it as fingerprint. Now this document and fingerprint are put together and sent from the sender side. See the diagram and we'll understand it. Right. The message digest needs to be kept secret. So how to keep this message digest secret? Should we perform encryption first and then put to hash function, or should we put to hash function first and then encrypt it? How to keep this secret? Should I apply encryption algorithm first and then result ki hash function apply cheyala? Ledu first hash function apply chesi vachina message digest document anni kalpi encrypt cheyala? Come on, someone answer to this question. Should encryption be done first and then hashing, or should hashing be done first and then finally encryption should be done? So answer is there. Yes. Say.
హ్యాషింగ్ చేసిన తర్వాత ఎన్క్రిప్ట్ చేయాలి.
Excellent. Why? The answer is there in the slide. Message digest needs to be kept secret. ముందే ఎన్క్రిప్షన్ చేస్తే సీక్రెసీ పోయింది కదా. ఇది ఎన్క్రిప్షన్ చేసే తర్వాత హ్యాషింగ్ చేస్తే where is message digest? Outside encryption. What should be done first? First hashing should be applied. Then the hash value and the original message both should get encrypted now. See, we are slowly complicating the process of sending and receiving messages now. First, we only thought of encryption and decryption, but now simple encryption and decryption are not enough. Now, before encryption, now I'm talking about algorithm again. What algorithm? Confidentiality is encryption. So now I'm talking about integrity algorithms here. First, apply integrity algorithms. That will give you a value. Then have this value and the actual data on both of them. Now apply confidentiality algorithms, encryption algorithms, right? Maybe when I go to the next topic, I may change this again. I may say that there is another algorithm before it. We will see as we go on. So message digest needs to be kept secret. Done. Right. See, this is the procedure, overall procedure. Just look at this diagram. It's so simple and self-explanatory. Now on the sender side, on the left side, Alice is trying to send the message. Alice has generated a message. The blue dog-eared corner page, annotated page, is the message. Alice has generated a message. Message is put to a hash function first. That hash function will generate a message digest. Now see what is being sent. Message digest and the blue dog-eared rectangle page document. The document and the message digest both are sent. I'm not even talking about encryption here. I'm talking about plain hashing, just hashing. Only integrity is provided here, not confidentiality. So the document and the fingerprint are sent to the receiver. Now look at the receiver. What is happening at the receiver? Receiver receives both. The message digest is received, the document is received. It puts the message digest aside. Received message digest is put aside. It takes the document and puts the document to the same hash function that the sender has put it through. The document is applied with the same hash function that the sender has applied on that document. So now the receiver will also generate a message digest. It will also generate a fingerprint, a message digest. Now the generated message digest is compared with the received message digest. See there, it is put to a flow chart is drawn there. It is put to a yellow decision diamond box. Is it same? Yes, accept the message. If it is not same, the space was missing here. Obviously, the hash value will change. The hash value will change. So the sender's hash value and the receiver's computed hash value, both will be different. If both are different, integrity of the message is missing somewhere. Something went wrong in between on the or over the network. Then simply the receiver discards the message and requests the sender to resend the message, maybe, or simply discard it. Done, right? So this is how a simple hash function works. But what is missing here in this? Hashing is good, message integrity is there, but what is missing?
Encryption.
Yeah, confidentiality, the encryption is missing. Again, sometimes we may need confidentiality, sometimes we may need integrity, but it would be better if a network can provide both confidentiality, that no one else can understand what is being communicated between these two people, and integrity. What is integrity? That the receiver receives exactly the same data that is sent by the sender. Both put together serve as a better service by the network service provider, right? So let's now enhance this algorithm. So before I enhance this algorithm, I want to give you some responsibilities, some functionalities. What is the criteria that a hash function should have? A hash function should have three properties to it. It is called one-wayness, weak collision resistance, and strong collision resistance. So what is one-wayness? As I've told you, encryption and decryption are bidirectional. One side the data can be encrypted, the other side the same data can be decrypted. The encrypted data can be happily decrypted to the same text that it was before encryption has happened. That is bidirectional. But whereas hash function, once you apply a hash function on the data, it gets converted or it generates a hash value. The hash value cannot be constructed back to the original message. It cannot. You cannot apply any algorithm on it. It cannot go back. So this is unidirectional. So your hash function should be so complex that it has the property called one-wayness. Never ever there should be a possibility to reconstruct the original message from the message digest, from the hash value. You should not be able to construct it back. First property. So now tell me, will this hash function be simple or complex? Complex. Now we say that it is complex. Instead of, we now change the answer, right? Now, weak collision resistance. See, I have contradictory statements there. Both the properties are actually opposite to each other. The first one says weak collision resistance. The second one says strong collision resistance. Are two properties different, sir? Okati weak antalu, okati strong antalu. Okati untadu kada. They are actually counterparts of each other, isn't it? Right? Then how can you guarantee that a hash function will have weak collision resistance and at the same time same hash function should have strong collision resistance? Here it is. Weak collision resistance is if a message is put to a hash function, a message A is put to a hash function, generates a hash value. Now, if the same hash function is applied on a message B, it should never generate the same hash value that it has generated for A. If a hash function is applied on message A, it generates a hash value. If the same hash function is applied on message B, it should never generate the same hash value that it has generated for message A. That is called weak collision. The collision is the same thing there. The hash value is same, colliding there, collision there, right? So that is called as weak collision resistance. The hash function should not be that weak. Here it is weak. If two messages put to the same hash function, two different messages put to the same hash function, if they generate the same hash value, what is the hash function you have used? Useless hash function, right? So that is called as weak collision resistance. It should be the property. Then comes to strong collision resistance. It is again a bit typical criteria here. If I apply a hash function on message A, if I apply a hash function on message A, it leads to a hash value. If at the same time Karthik applies a different hash function on the same message A, if Karthik's device also applies a different hash function, but the message is same, the message applied to the hash at my device, the message applied to the hash at Karthik's device, both messages are same, but the hash functions are different. They should never lead to the same hash value. They should never lead to the same hash value. That is called strong collision resistance. Your hash function should also be so strong. So when I'm talking about internal my device, I say that the hash function should have weak collision resistance criteria, property. When I talk about multiple devices applying multiple or different hash functions, the result should never be the same on the same message. The result should never be the same. Is this two correct properties or okay properties? Will you accept with those two properties? Do you think hash should have those properties? Hashing should have those properties. One is same hash function on two different messages should never lead to the same hash value. Two different hash functions on the same message should also never lead to same hash value. Will you accept this? Should this be a property of hash? Yes, they should be a property of hash function. They should be. Only then your hash function becomes complex. And the more the complex the hash function is, the better the integrity that is provided. Obviously it will have those three properties. More complex, one-wayness will be there, weak collision resistance will be there, strong collision resistance will be there, right? Let's go to the next slide. Now I have a question for you people. Of course, the solution is written there over the slide itself. Can we use a conventional lossless compression? I have talked about compression a couple of classes back, compression and decompression. Can we use that compression technique as a hashing function? You looked at the slide, they will now answer it. We cannot. Why? Because we can always decompress a compressed message. A compressed message can always be decompressed. అట్లా లేకపోతే మనం పంపించిన ఫోటో మన కోతి లెక్క వస్తుంది. నా ఫోటో పంపిస్తే కోతి లెక్క వస్తుంది, నీ ఫోటో పంపిస్తే ఇంకెట్లా వస్తుంది, ఇంకా విచిత్రంగా వస్తుంది, అంతే కదా? So a compressed message can always be decompressed. Photo here is the message. Obviously it is zeros and ones, isn't it? So compression has bidirectional property. It gets compressed, it gets decompressed. The original photo is seen again at the receiver. Can I use that compression technique as a hashing function? Compression technique was so complicated. You remember the DCT equation I have shown you? It was so simple, isn't it? Very easy. It was put to two summations. It was put to cosine values to lot of summation from I equal to 1 to x and j equal to 0 to x and j equal to 0 to y with cosines in between. That was so easy, isn't it? It was very, very complicated. The most complicated algorithm that we have seen, or the mathematical equation that we have seen, was DCT. Still, that was so complex, but still we cannot use that as a hashing function. Why? Because it is reversible. It is reversible. The first criteria of hashing itself is it is one-wayed. It should never be reversed. I have one more question. Can we use checksum? Data link layer lo checksum నేర్చుకున్నాం కదా. Can we use checksum as hashing function? Yes. Checksum is a error detection technique, not correction technique, not reversible technique. It is only one-way technique. Checksum ni compute చేయడం వరకే మన పని. లాస్ట్ కి కంపేర్ చేస్తాం అంతే. We just compare at the end. We won't even retrieve or get the original data. right? So checksum can be used, but checksum is a simple algorithm. You will see algorithms as I go on. I'll show you only one algorithm as an example of message integrity providing algorithm. You will see how complicated, not complicated. Again, I have to reframe it. Complex, not complicated. Complex. How complex the algorithm will be. Let's go ahead now. So that, can we use checksum? The answer is yes. A checksum function is not reversible. It meets the first criteria, but it is not acceptable. However, I have written there as a second sentence. However, it does not meet the other two criteria called strong collision resistance and weak collision resistance. So we cannot use it. Initially, we can use it, but actually, it should follow all the three properties. So here is an example of a hashing algorithm that is most commonly used in today's world. Now, lot of message integrity service providers use this algorithm. Now it is enhanced. The algorithm I have shown, I'm showing you there is called as SHA-1, SHA-1, Secure Hash Algorithm 1. But nowadays we are using SHA-512, 512. Of course, SHA-1 also takes 512 bit, but I'll simply talk about SHA-1 here. We are not into the subject actually. This is only a topic for us in our subject. So see this. There is a series of processing that happens to data. The actual data that is coming from the top, can you see that big line I have drawn, horizontal line that I have drawn, and there is a message written on top of it. Message, that is the message. And the message is what? It is a multiple of 512-bit blocks. So each part of the message that is put to one processor, the length of that data is 512 bits. So one block of data is 512 bits, and at once, some n such blocks are given as an input to SHA algorithm. N such blocks. N, I'll tell you in the next slide, I'll tell you what is the value of n. But for now, simply understand, each block of data is 512 bits. N such blocks are fed as an input to the SHA algorithm processor. So that is the blue rectangles you see there. They are fed as an input with black lines to the processor. There is another input coming to it, pink line. So it started way at the left. At the left. What is it? There is a buffer initial value. I'll show you how this buffer value comes later. There is a buffer initial value of n bits. N again. N is n. I'll tell you how much is that n in the next slide. Buffer initial value of n bits, that is the first input to it. See that pink line? It comes as an input. The next input to the processor is 512 bits, a block of n blocks. Out of n blocks, one block is that 512 bits. Both are given as an input. Both are the inputs to the first processor, only. And the processor gives an output of n bits. So what is the length of input? Total length of input. What is the total length of input to the first processor?
512 plus n bits.
Excellent, sir. That's it. Very simple. 512 plus n. N and so tarvata chuddam. But for now we know that it is 512 plus n. How much ever it is. Adi mottam kalipi input aithe output n bits vastundi? N bits. So you should now understand that it creates only a n-bit message digest. Input is 512 plus n. Lot of input is given to it. But the output of the first round, I'm only talking about the first processor here. I have dot like that. I have so many processors. We will see it in the next slide. So the output is just n bits. So it cuts down the huge input block to a normal output message digest. And then again, n bits will be provided as input. And that output n bits is provided as input to the second round, second processor. Again, what is the input, other input to the second processor? The second block of data. I told you, one block of data is 512 bits. We'll have n such blocks. The second block will now be the input. Do you really think ఒక ఫస్ట్ రౌండ్ అయిపోగానే అక్కడ మెసేజ్ డైజెస్ట్ వస్తే దాన్ని యాడ్ చేసి పంపిస్తారు అనుకుంటా అలా see how much it goes through for that big message not one 512 bits కి వచ్చిన అవుట్పుట్ n కాదు 512 dot n for all these big data chunks only one message digest is created. Finally, what is the length of output? Finally, last
n bits.
n bits. So if for example I have a data of 512 into 10 blocks 10 కంటే ఎక్కువ ఉంటాయి. Generally I'm taking an example. 512 into 10 is 5120 bits ki kalipi only the message digest length will be just n bits, just n, and the n I'm revealing it is 160 bits, 160. So if I have 20 blocks of 512 bits of data, that will be about 10,000 data bits. 10,000 data bits put to one SHA algorithm will give you n bits as output. What is n? I've just told you
20.
160. 160 is the length of n bits. So if it is 30, if it is 40 blocks of 512 data, 20,000 bits will be input, only 160 bits will be output. That's the complexity of your SHA algorithm. It takes a huge message as an input, puts to some hashing algorithm, whatever hashing algorithm. We are not into this subject. We are only talking about the concept here. So don't worry about the algorithm. That is the luckiest part we have here. In your next semester, you will understand the algorithm again. 10,000, 20,000 bits, 160 ఎట్లయితే అనేది, that is our next semester, not now. For now, you only understand that huge message is just digested. అరిగించుకున్నది అన్నట్టు. Why we call message digest? It is digested. 9,900 bits are digested. Only 160 bits have come out. That is called as message digest, right? So SHA-1 hash algorithms create an n-bit message digest out of a message of 512-bit blocks. The block size is not told here, but each block, number of blocks are not told here, but each block will have 512 bits. But finally, I have revealed something. SHA-1 has a message digest of 160 bits. It is categorized into 5 words. Words, do you come across this word? One bit is called 1 bit register. So say 1 bit is single bit, obvious. 1 bit register is called flag. 4 bits put together, what is it called as?
Byte.
Nibble.
Yeah, nibble, N-I-B-B-L-E. 8 bits put together, what is it called as? Byte. Above 8 bits, what is the nomenclature used? 16, 32, 64, 128, 256, 512, 1024, whatever it is. Above 8 bits, I know now have single bit, nibble, byte. Above 8 bits, what is the nomenclature used? So for whatever length above 8 bits, it is called as word. W-O-R-D, word, yeah, word. The word refers to any size above 8. But we have to tell it. When you say a word, you cannot simply blindly say word. You have to tell 16-bit word. You have to say 32-bit word, 64-bit word. Ani cheppali kachithanga. Word ante ardham kaadu malli. Word can be anything above 8 and a multiple of 2. Power of 2, sorry, not multiple of 2, power of 2. So here, what is the size of word here? 32 bits. 32 bits is the size of word. How many such words? 5 words. So 32 into 5 is 160. So that is the length of your message digest. 160 bits grouped as 5 words. Each word will be 32 bits. Now here is your SHA. So complicated, isn't it? I'll see if I can zoom it a little bit. Yeah, right. So now that 5 words, now I'll zoom it back. I go up, right. What are the 2 inputs? One pink line and one black line, is it? Pink line, how much is the length of pink line? Pink line input length.
160.
160. Excellent. Black line input length is
512.
512. Right. Let us now we should show two inputs here. I should show you two inputs here. Right. Now the first input is from the top. A, B, C, D, E. How many is this? 5. 5. Where did I come across this 5 word? Here. Message digest. 5 words. Each word is of 32 bits. So what is the input that is coming from the top? 160 bits of message digest. 160 bits of message digest. Where did you get it from? The previous block. The previous block. Can you see? Here. Pink is always an input coming from the previous output. The previous output is fed as an input to the next input, next block. Again, the output of that block is fed as an input to the next block. So it comes from the previous processor. No doubts? No doubt?
ఎట్లా సార్ బఫర్ ఫిల్ అయి ఉంటుంది.
సో ముందు నుంచి వస్తుంది అంటే సరే రౌండ్ 2కి రౌండ్ 1 అవుట్పుట్ వస్తుంది, రౌండ్ 3కి రౌండ్ 2 అవుట్పుట్ వస్తుంది, మరి రౌండ్ 1కి ఎక్కడ వస్తుంది అబ్బా? బాగానే ఉంది. వాట్ ఎవర్ ఐ సెడ్ ఈస్ కరెక్ట్. ది 160 బిట్ ఇన్పుట్ విల్ కమ్ ఫ్రమ్ ది ప్రీవియస్ rounds output. Round 2 there is always round 1, so you get an input. Round 3 you get round 2's input. Round 2's output will come as an input. Then what about round 1? Where is the input coming from? So there will be initial buffer random value, 160 bit random value. For now we will think it is a random value, but when we go to next semester subject, again there is a rule for it, how that 160 bits come into that buffer, that is buffer location. So round 1 ki initial buffer untadi, akkada nunchi 160 bits vastayi. ఎట్లా వస్తాయి ఏంటి అవి? దెర్ ఈస్ ఎ ప్రాసెస్ ఫర్ ఇట్. నాట్ వీ డోంట్ వాంట్ టు వరీ అబౌట్ ఇట్ రైట్ నౌ. ఓకే, సో నౌ that is the first input to round 0 or step 0. Look at, there is another input to it from the right side, the W, that is the first 512 bits. First 512 bits. Okay, so two inputs, 512 bit data and 160 bit message digest. They are put to step 0. What is the output of step 0? How many bits is the output of step 0?
160.
160. That's what I am trying to tell you. Every round will only generate an output length of 160 bits. Now that is fed as an input to the second round. See here, the output of the first round is now fed as an input to the second round, where second 512 bits are taken, new 512 bits are taken. That's the difference between your encryption algorithm and hashing algorithm here. What happens to encryption algorithm there? It goes to several rounds, but it is applied on the same data. Did you get it or not? Since it is reversible, how many ever rounds functions it has gone through, all that is performed on only one input data. 128 bit కావచ్చు, 64 bit కావచ్చు, but input data is only one. It goes through 16 rounds of encryption. But whereas here, first round, first 512 bits, second round, second 512 bits, అట్లా 10 రౌండ్ల కలిపి 512 bits కలిపి మొత్తం కలిపి వచ్చే అవుట్పుట్ ఎంత? What is the length of the output after 10 rounds, 20 rounds, 30 rounds, whatever it is?
160.
That's what I am trying to tell you. So how much ever is the length of the input message, the length of output message digest will only be
160.
160. That's what you should be understanding, right? So that's your first round output. First round output is fed to second round output is fed to third round, dot, 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 dot. I think you have step 79. So how many steps? 0 to 79, which is 80 steps. And even after 80 steps, the initial 160 bits are again fed as an input. See here, a pink line small in the last. So finally you get a 160 bit message digest. Do you really think this is reversible? Look at that process. Look at that number of steps it goes through. Look at the way it is actually compressing about thousands of bits into just 160 bits. Do you really think this is reversible? Impossible.
Complex.
Very complex. Impossible. Next to impossible, even rather, I would say. Done? Right. So that's how a SHA algorithm works. So that's message integrity. Hope you're understanding, hope you're following. Message confidentiality completed. Message integrity is completed. We still are left with three more things, three more services. Complex part is almost over. From now on, it should be very simple, but you should understand it. That's all. That is all the concern here. So let's go with the next service provided by the network. Message authentication. Confidentiality is privacy. So that even some user in between gets the data, they should not be able to understand it. Then comes to message integrity. Message integrity is not secrecy. It is about providing the trust. Receiver will receive the exact data that is sent by the sender. That is integrity. Now comes the third one, authentication. What is authentication? Why we need authentication? Look at the introduction there. A hash function per se, let us just say, cannot provide authentication. Digest created by the hash function can detect any modification in the message, but it will not detect whether the sender has sent it or not. It will only detect whether the message is perfect or not. ఎవరు పంపించిల్లు అది చెక్ చేస్తుందా? లేదు కదా. Is it really checking the identity of the sender? Is it authenticating the sender?
No.
No, it is not. So message authentication is still a requirement. Don't you really think we need message authentication also? See, slowly we are now understanding it's not just a message that goes from sender to receiver. పొద్దున్న లేస్తే 190 వాట్సాప్ మెసేజ్ పెట్టుకుంటాం కదా, మనకు మనం ఒకరు అఫ్కోర్స్ నాకు కాదు, మీరు సారీ. Look at how complicated and how much effort should your device, just the device, it's not about ఎవరో వచ్చి మనకు ప్రొవైడ్ చేస్తుంది ఇక్కడ, మన డివైస్ మన నెట్వర్క్ అంతే రెండే. You are connected with a network. If you have Airtel SIM or you have Vodafone SIM or whatever it is, you are connected with a network. You have a device. Both together, we are not done yet. We are still studying. Last మొన్న నేర్చుకుంటాం ఇంకా ఒక్క మెసేజ్ పంపిస్తే ఏం జరుగుతుంది అనేది, isn't it? Now we come to this service where message authentication is also important. When a message is sent from a sender to receiver, confidentiality ఎంత అవసరమో, integrity ఎంత అవసరమో, equally authentication is also required. Done? Right. Let's go and see what authentication functions we have. There is only one algorithm that I would say here. There are a lot of other algorithms also, but one algorithm. I just want you to understand what they are. That's it, right? Called MAC. So there is now a small confusion. Did we come across MAC before? MAC. Did we come across MAC before?
MAC address.
Yes. In which layer did we come across MAC address? MAC address is also called as
IP address.
Logical address is called as IP address.
Physical address.
Physical address. Okay. Sultan? Right. Physical address. Right. So MAC address is also called as physical address. Which layer did we come across MAC address?
Data link layer.
Data link layer. Good. Nice. So you are following me so closely. What is the full form of MAC? Sachin Gore. Medium access control. Right. So this is security. That is networks. Both are two different subjects. అక్కడ మ్యాక్ ఇక్కడ మ్యాక్ వచ్చిందని రెండింటికి ఫుల్ ఫామ్ సేమ్ ఉంటాయంటే నేను ఏం చేయలేను ఇక. దిస్ ఈస్ డిఫరెంట్. దిస్ ఈస్ ఏ అథెంటికేషన్ టెక్నిక్. That is a sub-layer of data link layer. Their MAC is a sub-layer. Data link layer has two sub-layers in it called LLC and MAC. Logic link control and medium access control. Here this is a algorithm. This is a authentication algorithm provided by the network as a service. MAC, message authentication code. There it is medium access control. Here it is message authentication code. Right. So what is this message authentication code? Again, hashing అర్థమైతే మొత్తం వస్తాయి అబ్బా. 99% మనం whatever slides you are going to discuss from now on, at least 90% of the slides you will understand if you have understood message digest. Hashing and message digest is the basic. Now you will understand all the remaining slides so easily. So what is the aim of MAC function? MAC will help in authentication, message authentication. MAC will help in message authentication, not encryption, decryption, not hashing. This is about message authentication, not integrity, not confidentiality. See what happens. Alice is trying to send a message to Bob. Now, I'm not talking about integrity here. I'm not talking about confidentiality here. I'm talking about authentication, the third thing that happens, authentication. So, the message that is sent by Alice is put to a MAC function. Message authentication code. MAC means message authentication code. A MAC function uses a key. This is not an encryption key or a decryption key. This is a authentication key. MAC function uses a key. Symmetric key. Hope you understand what symmetric key is now, because it's already finished in the last class. So a symmetric key is used and a MAC function is applied on the document. It generates a MAC value. If hashing is applied, it generates a hash value. If MAC is applied, it generates a MAC value. Done? Now, the document and the MAC is sent together to the receiver. Now, the receiver receives the document and the MAC value generated by the sender. MAC value is put aside for the moment. Received document is put to the same MAC function with the same key that the sender has used. Same MAC function with the same key that the sender has used should generate the same MAC value. Now, that MAC value that is received from the sender is compared with the generated MAC value here. If both are same, it's fine. Message is accepted. Authenticated. If both are not same, for some reason, authenticity is failed, the message is discarded. That is how authentication happens. This is not integrity. This is authentication. So before encryption happens, what else should happen? We actually talked about encryption first, but before encryption, according to our knowledge, till now, manakunna teliyu prakaranga, manaku ardhamaina dani prakaranga, what else should happen? Hashing, which is integrity. Integrity should be provided.
Then MAC,
which is authentication, should be provided. So authentication should be provided first, then integrity, then encryption. చూసినా ఒక మెసేజ్ ఇట్లా పెట్టి ఇట్లా సెండ్ కొడితే ఇట్లా పోవాలి, అట్లా బ్లూ టిక్స్ రావాలి కదా, రైట్? See how much is happening, and we are not done yet. We are still at the authentication part. We still have to go to remaining to non-repudiation as well as entity authentication. There are two more things, right? Even entity authentication పక్క పెట్టినా సరే మెసేజ్ కి 4 అయితే కంపల్సరీ. So this is the MAC functionality, but we'll still complicate this a little bit. MAC was not up to the mark, or it had some disadvantages, which I don't want to discuss now, because I am not explaining you the MAC function here. I don't want to discuss the disadvantages also. Ardhamaithe adi radu. So we want to overcome the disadvantages of MAC. Then came HMAC, hashed MAC. Hashing and MAC put together. So hashed message authentication code. So now what happens is, first a message is applied with MAC. What will be MAC? No, MAC. Look at the key on the left side. Message ఒకటే hash కి పెట్టినామా? Message కంటే ఇంకెక్కువ ఉంది hash కి పోయేది. Concatenation. There are two things that are put to hash value. There is a concatenation symbol in between. Can you see? Key and message.
Yes,
yeah, key and message. So what is that key? Shared key. Mona class lo cheppina. Simple black key is private key. Simple pink key is public key. A key with shaded black background is shared key, symmetric key. So I told you in MAC in my previous slide. Are we using the same key? Sender and receiver? Yes. So it is symmetric? Yes. So first, the sender's message is applied with MAC. MAC with the shared secret key, which generates a MAC value. That MAC value is now applied to hash. That will generate a HMAC, hashed message authentication code. Again, see there, again it is now added with the secret key. Now added with the secret key. What is the advantage? What is the advantage here? Hashing is unidirectional. మధ్యలో ఎవరికన్నా HMAC వాల్యూ దొరికినా సరే ఏం చేయలేరు. But if I go here, if the key is lost, if the secret key is lost, everybody can generate the same MAC value, isn't it? Did you get it? If the secret key is lost, just the same problem with your encryption and decryption. Key పోతే మొత్తం పోయినట్టే symmetric లో. Key పోతే మొత్తం పోయినట్టే symmetric లో. Everything is gone, right? So this is why we have a key. First, that key is used to apply with MAC. Then a hash is applied on it. After applying hash, you get HMAC, which is hashed MAC. Hashed MAC తో పాటు మళ్ళీ key పెట్టేసి you put to a hash function again. Then comes your HMAC message digest. That is sent along with the actual message. That is not the message that is sent. That is for authentication only. That HMAC is generated for authentication only. Again, on the receiving side, same procedure is done by the receiver. Again, a HMAC is generated. That HMAC and this HMAC are compared. If both of them are same, message is accepted. If they are different, message is rejected or discarded. Simple. The procedure is same everywhere. Generating a message digest or a MAC or a HMAC, sending it along with the message to the receiver. Receiver receives the message and the digest or the MAC or HMAC uses the message to generate a new or his own or her own MAC or message digest. Compare it with the received message digest or received MAC. If both of them are same, receive the message. If they are different, daal mein kuch kala hai, reject the message. Simple, right? So that's message authentication, MAC. For message confidentiality, what we use? Encryption and decryption algorithms, which we have learned in the last class. For message integrity, what do we use? Hashing. The algorithm is SHA, secured hash algorithm. For message authenticity, what do we use? MAC, HMAC, message authentication code and hashed message authentication code. Now we go to the fourth one, message non-repudiation. Let us quickly wind it up. What am I just in 21st slide? I still have to go through 40 slides, nearly 40 or the total number of slides. So now here is a new concept called a digital signature for message non-repudiation. Very simple technique to understand. Did we all go to banks, or our fathers have been to banks, right? You want to withdraw some money using a checkbook. Check ichi money తీసుకోవాలి. You write some amount on it. That is not important. Of course, that is important, how much should be given, but that is not the most important thing. You write it in words. Account number is already printed on it. This is all very simple. There is one authentication that happens on that leaf. What is it?
Signature.
Excellent. Signature is the most important thing. The moment you produce the check to the teller, the first thing the teller checks is not the number on it, not the amount on it, not the words on it, nothing. The first thing that they check is they have your signature registered, scanned and registered. They'll open that registered, scanned signature, compare the scanned first time మీరు పెట్టిన signature ni ఇప్పుడు మీరు లీఫ్ మీద పెట్టిన signature ni, they compare it. If both of them are same, message digest, that is what is message digest, right? If both of them are same, check is accepted. If both of them are different, manager simply rejects your check, or they'll ask you to re-sign twice or thrice on the back of it. And then they'll compare it again. If not, they'll simply reject it. It's the same thing here. The signature హియర్ ఇస్ డిజిటల్. అంటే సంతకం పెట్టారు ఇక్కడ, సెండర్ ఏం సంతకం పెట్టారు ఇక్కడ, బట్ సెండరే అని చెప్పడానికి ఓ చిన్న ప్రొసీజర్. Just like MAC, just like HMAC, just like hashing, whatever it is put to a procedure. It generates a signature. Hashing generates a message digest. MAC generates a MAC value. HMAC generates a HMAC value. SHA generates a message digest of 160 bits. Similarly, digital signature generates a signed message digest or a signature. You want to call it a signature, you want to call it simple signature. Right? This is used for sender's authentication, not message authentication. Message authentication is different, sender authentication is different. Okay? Right. So digital signature. When Alice sends a message to Bob, Bob needs to check the authenticity of the sender, Alice. He needs to be sure that the message comes from Alice, and I told you, not from Eve. The third person who always intervenes in between is Eve. Bob can ask Alice to sign the message electronically. In other words, an electronic signature can provide the authenticity of Alice as the sender of the message. This is called as digital signature. Then what is that signing? We will see. A digital signature needs a public key system. It is using a public key system. See here, till now MAC, HMAC used symmetric key, simple symmetric key. But now we are talking about public key, which means asymmetric. When do we come across public and private keys? When it is asymmetric keys. Yeah. So a digital signature needs public key system. See the difference between encryption and decryption while using public keys. Signing the message itself in the digital signature. See the difference. Generally, let's go back, recall. Alice wants to send a message to Bob. Alice will encrypt. If I'm talking about encryption is the thing here. Alice will encrypt the message by using, if it is public key cryptography, if it is asymmetric cryptography, Alice wants to send a message to Bob. Alice will encrypt the message by using
Public.
what?
Private key.
Encryption.
Shared key.
నీ మెయిల్ ఐడికి పాస్వర్డ్ చెప్తావా? అందరికి నీ మెయిల్ ఐడి చెప్తావా?
Mail ID.
మరి మెయిల్ ఐడి ప్రైవేటా పబ్లికా?
Public.
Then what will you give to everyone?
Public key.
Public key. So if I have to send you a message, I have to encrypt the message by using your public key. That is known to me. నాకు తెలిసింది కదే, నాకు ప్రైవేట్ కీ ఇవ్వవు కదా నువ్వు, రైట్? సో encryption always happens with public key of the
Sender.
రిసీవర్.
నేను నీకు మెసేజ్ పంపిస్తాను, నీ మెయిల్ ఐడి టైప్ చేస్తాను, నా మెయిల్ ఐడి టైప్ చేస్తాను, టూ దగ్గర నీదే కదా, రైట్? సో ఎన్క్రిప్షన్ యూజింగ్ asymmetric key, always the sender will use the public key of the receiver to encrypt the message. Sender will use the public key of the receiver to encrypt the message, and then encryption is done. But in a digital signature, it is quite opposite. నేను పంపిస్తున్నా ఏమని చెప్పుకోవడానికి, నేనే పంపిస్తున్నా అని చెప్పుకోవడానికి కావాలి కాబట్టి ఎవరి పబ్లిక్ కీ యూజ్ చేయాలి? నా పబ్లిక్ కీనే యూజ్ చేయాలి కదా. నేనే పంపిస్తున్నా అని చెప్పుకోవడానికి ఏం యూజ్ చేయాలి? మై కీ. నేను కావాలని రాంగ్ చెప్పిన. మై కీ. షుడ్ ఐ యూజ్ మై పబ్లిక్ కీ ఆర్ షుడ్ ఐ యూజ్ మై ప్రైవేట్ కీ? ఇఫ్ ఐ యూజ్ మై పబ్లిక్ key, it can be decrypted by using
public key.
If I use my public key to encrypt it, it can be decrypted by using only
private key.
My private key. Can someone decrypt it?
No.
Only I can decrypt it. నేనే కదా. మరి నేను నా పబ్లిక్ కీని యూజ్ చేసి ఎన్క్రిప్ట్ చేస్తే దాన్ని వేరే వాళ్ళు ఎట్లా చెక్ చేస్తారు? నేనే అని ఎట్లా తెలుసుకుంటారు? కష్టం కదా. They cannot decrypt it. I have used my public key to encrypt it. It can be decrypted by only using my private key. Will anyone else know my private key? Nobody. Then how can they understand that it is me? How can they decrypt it? They cannot do it, right? Then what should I do? Andarki em telusu?
Public.
Na public key. So simple. That's it. Very simple. My public key is known to everyone. If I encrypt using my private key, can they decrypt it?
No.
Mhm.
No.
These two keys are like, you use one key to encrypt, the other key should be used to decrypt it. These two keys are like, they are asymmetric, but తాళం నీకు అరుణ్ చెప్పిన తాళం వేస్తే సిమెట్రిక్ అంటే సేమ్ తాళం చెవితో తాళం వేయాలి, సేమ్ తాళం చెవితో తాళం తీయాలి ఇంటికి. అసిమెట్రిక్ కీ అంటే తాళం వేసేటప్పుడు ఒక తాళం యూజ్ చేస్తాం, తాళం తీసేటప్పుడు సీక్రెట్ కీ వేరే కీ యూజ్ చేస్తాం. ఎవరైనా తాళం వేయచ్చు, తాళం తీయడం మాత్రం సీక్రెట్ కీతోనే వస్తుంది. Done. So they have that relationship. So now what will I do in digital signature is, I know that everybody knows my public key. So I will encrypt the message by using my private key. My private key is known only to me, so I can encrypt it. And once encrypted, everybody can decrypt it. Whoever has my public key can decrypt it. Similarly, receiver will also have my public key. They will decrypt it. But message దొరికిపోతుంది అంటారా? ఎవరైనా డిక్రిప్ట్ చేసుకోవచ్చు అంటే మెసేజ్ కూడా దొరికిపోతుంది కదా వాళ్ళకి.
Yes.
Message is different. We are talking about non-repudiation here. Message తో పాటు పంపించేది నేను. Message తో పాటు పంపించేది డిజిటల్ సిగ్నేచర్. Is this becoming a bit complicated now?
Yes, sir.
Yes, I know. I understand. Right. See this. This is the message. This is the message. Whatever we are discussing till now, first encryption decryption నేర్చుకున్నాం. కానీ తర్వాత when I came to integrity, what did we understand? Before encryption decryption, integrity is done and then encryption is done. Then when I came to authentication, what did we conclude? Authentication, integrity రెండు అయిపోయినాక encryption చేయాలని చెప్పిన మెసేజ్ ని. ఇక్కడ కూడా అంతే. I'm not talking about message. I am telling you that this message is put to a digital signature algorithm. This algorithm will encrypt the message or will convert the message by using my private key. See, closely follow this. I am not talking about message before sending. Before sending, it is put to a digital signature. When it is put to a digital signature, because I want to provide it my authentication, నేనే అని చెప్పాలి అంటే నా దగ్గర ఒకటే ఒక బ్రహ్మాస్త్రం, నా ప్రైవేట్ కీ. సో ఐ ఎన్క్రిప్ట్ దిస్ మెసేజ్ విత్ మై ప్రైవేట్ కీ. దట్ విల్ బీ గివింగ్ మీ అన్ అవుట్పుట్ వస్తుంది, నాకు ఒక అవుట్పుట్ వస్తుంది. నా దట్ అవుట్పుట్, వాట్ ఈస్ దట్ అవుట్పుట్? మెసేజ్ పుట్ టు మై ప్రైవేట్ కీ. దట్ అవుట్పుట్ ఈజ్ కన్కాటినేటెడ్ విత్ ది యాక్చువల్ మెసేజ్. మెసేజ్ ని యూజ్ చేసుకున్న ఒకసారి కానీ పంపిస్తా అందులో ఇంకా నేను యూజ్ చేసుకొని ఒక అవుట్పుట్ తీసుకొచ్చా. That output is my authentication. This output is my authentication. That output is concatenated with my message, put together. ఇప్పుడు నేను అప్లై చేయాలి దీని మీద? ఇంటిగ్రిటీ కావాలంటే ఇంటిగ్రిటీ అప్లై చేయాలి, మెసేజ్ అథెంటికేషన్ కావాలంటే మెసేజ్ అథెంటికేషన్ అప్లై చేయాలి. ఫైనల్లీ confidentiality. Now I will encrypt all this. See this now. You have to answer me correctly now. Every one of you, whoever is listening and replying me now, you have to answer me this correctly. ఇదేమో నా అథెంటికేషన్ కోసం యూజ్ చేసిన ప్రొసీజర్, నా ప్రైవేట్ కి యూజ్ చేసిన నా పబ్లిక్ కీతో దాన్ని డీక్రిప్ట్ చేసుకోవచ్చు, నేను కాదనట్లే. కానీ అది ఎక్కడుంది చూడండి, ఇక్కడ ఉంది. దట్ ఈస్ హియర్. యాక్చువల్ మెసేజ్ ఈస్ హియర్. ఆల్ దిస్ ఈస్ నౌ encrypted. Now I am sending it to Srija. Srija, you are listening to me, right? So now I am sending this to Srija. Now I am applying confidentiality. Digital signature అయిపోయింది, నేను confidentiality అప్లై చేస్తాను ఇప్పుడు. లాస్ట్, what will I use? If I am using asymmetric key cryptography, what will I use here? శ్రీజాకి పంపించాలి. నాకేం తెలుసు శ్రీజ దగ్గర నుండి? Public key. So what should I use here?
Public key.
Your public key. See this?
Yes.
So now this entire thing is encrypted by using your
Public key.
Your public key. Now can somebody decrypt this? How can you decrypt this?
Using public key.
Encryption I have done using your public key. How can you decrypt this?
Receiver's private key.
Receiver's private key. Excellent. Who is receiver here? Srija. So who can decrypt this? Who has the private key? Who has the
Yeah,
private key? Yeah, Srija has the private key. Only Srija can decrypt this entire message. Chudandi. First packet lo 5 తీసేస్తాను ఇప్పుడు ఇక్కడ. I have removed this. She has decrypted this message. Now she got two things. This output and the actual message. Now, ఈ output నాదేనా కాదా? This should be decrypted. This should be decrypted. How did I encrypt this?
using your
My
private key.
private key. How can you decrypt this? My public key. Do you have my public key? Yes, everybody
Yes.
will have my public key. కానీ ఇది బయటికి రావాలంటే ఫస్ట్ ఈ డబ్బాలోంచి ఇది బయటికి రావాలంటే ఎట్లా వస్తుంది? I have encrypted this entire. That's why I told you confidentiality is the last thing that I'll do. I have encrypted this entire thing by using Srija's public key. Only Srija, only recipient can decrypt this. ఈ పైన ఈ డబ్బా తీసేస్తేనే లోపల దాని గురించి ఆలోచించాలి ఫస్ట్. So nobody will receive this. Did you get it?
Yes, sir.
How am I providing my authentication inside the message, entire message before encryption? See, that's what I told you. This is a very complex subject. It's not that simple to understand in 1 or 2 classes. It should be dealt very slowly, then it gets injected into your mind, because you still have confusion of what public and private keys are and what encryption and decryption is. అంత ఈజీగా రావట్లేదు. యూ హ్యావ్ టు స్టడీ, చదవాలి. కాకపోతే లక్కీ థింగ్ ఈజ్ యూ జస్ట్ హ్యావ్ టు అండర్స్టాండ్. మరీ కాంప్లెక్స్గా లోపలికి పోవట్లేదు, మనం సింపుల్గా అర్థం కావాలి. హోప్ యూ గాట్ దిస్.
Yes, sir. Clear.
Yes, clear. Good, nice. Thank you. So this is how a digital signature is used. Digital signature is used to provide my authenticity, sender's authenticity. Now, if I have used my digital signature and sent you a message, రే పొద్దున నేను పంపించలేదు ఇది అని చెప్పడానికి నాకు రైట్ ఉంటుందా? ఇంకా can I have that right to deny this? I have implied. No, that's it. So simply I am giving, the network is providing which non-repudiation option here. Integrity is provided, confidentiality is provided, message authentication is provided. Now sender's authentication is also provided here. Non-repudiation is also provided. Done? See, that's the difference I've told you. In crypto system, which is confidentiality, we use private and public keys of the receiver generally. But in digital signature, we use private and public keys of the sender, నా private key. నీకు పంపిస్తున్నా కానీ ఫస్ట్ ఏం చేసినా నా private key యూజ్ చేస్తున్నా. That is the difference between your crypto system and the digital signature. Okay? Right. So this is how it happens with a digital signature. The procedure is same. Everything will be same again. ఒక్కసారి ఒక డయాగ్రామ్ అర్థమైందంటే అన్ని డయాగ్రామ్స్ దే ఆర్ ఆల్ సేమ్. యూ జస్ట్ హ్యావ్ టు నో this procedure. That's it. Got it? Right. So today's world, digital signature is most widely used by all the network service providers to provide message integrity also. And it also provides message authentication. It also provides sender's authentication. So digital signature serves for 3 things. ఇప్పటిదాకా చదువుకున్న అల్గరిథమ్స్ అన్ని పక్కన పెట్టచ్చు. ఫర్ పర్ సే message authentication is provided, sender's authentication is provided, message integrity is also provided. Right. So we can use a third party. Instead of we both exchanging the keys and doing all this, we can use a trusted center. All the users that who wants to send and exchange, receive messages, they can take the help of a trusted center. Okay. Right. This is too deep, and I think we just have to understand whatever I have told till now. That should be enough. Then comes to the final thing is entity authentication. I don't know if we have time. Okay, I'll quickly wind up in 5 minutes because this is very easy to understand. In the complicated. Right. Entity authentication is a technique designed to let one party prove the identity of the another party. An entity can be a person, a process, a client, or a server. The entity whose identity needs to be proved is called the claimant. I go to an ATM center. I am the claimant of the money. I have to enter a PIN number. Isn't it? I want to log into my mail ID and check my mails. I am the claimant. I want to log in. I'll click on my user ID first, but then I have to provide my password. Right? So they have to prove themselves. The claimants have to prove neenu neene and prove chesukovali. Neenu neene and prove chesukovali. That is what is entity authentication. Neene ra babu Sandeep ni ani cheppali. Right? So this is done in 3 different ways. From very old to very new. Something that is known to me, something that is possessed by me, something inherent to me. Something that is known to me, PIN, password, secret key, they are known to me. But does that really prove that it is Sandeep? నా పాస్వర్డ్ నీకు తెలిస్తే నువ్వు కూడా లాగిన్ అవ్వచ్చు. నా పిన్ నెంబర్ నీకు తెలిస్తే నువ్వు డబ్బులు విత్డ్రా చేసుకోవచ్చు. చెప్పాలి నా పిన్ నెంబర్ 4 stars. Okay, right. So try to go to ATM center and withdraw money from my account. So something that I know is a PIN, a password, but do you really think this is serving as entity authentication? No, anybody can withdraw money if they know my PIN number and if they have my card. Anybody can log into my inbox if they know my mail ID. Mail ID is public key anyway. If they know my password, enough, right? So that is the first generation entity authentication, pins, passwords, and everything. Something that I know. Then why something that I know? The second one is something that is possessed by me, something that I have. A card, a RFID reader, RFID scanner, right? A license, a passport. These are all something that I possess. They cannot be given to any other person. Na driving license patkoni pakkana pote tiskevelli lopala istaru. That is not possible, right? So something that I possess is the next one, which is much better than something that I know. PIN, password can be stolen, but this provides as a very good entity authentication. దాని మీద నా ఫోటో ఉంటుంది, దాని మీద నా పేరు ఉంటుంది, సిగ్నేచర్ ఉంటుంది. There are a lot of things on it, right? So the second generation is really good, something that I possess. License, passport, all that are the things that I possess. What is the disadvantage then? What is the disadvantage? First దే బెటర్ తెలుసా ఇట్లా చూస్తే. సంథింగ్ దట్ ఐ నో, ఎప్పుడు నా మెదడులో ఉంటుంది, నా మెదడు నాతోనే ఉంటుంది, తీసి పక్క పెట్టి రాను కదా. బట్ సంథింగ్ దట్ ఐ పొసెస్,
Lost when it is lost.
You may lose it. You have to remember it and carry it. ఎన్నిసార్లు మర్చిపోం మనం ఏదైనా వస్తువుని కదా. సో కంపేర్ చేస్తే బెటర్ ఇన్ సెక్యూరిటీ, బెటర్ ఇన్ ఎంటిటీ అథెంటికేషన్, బట్ ఇట్ సఫర్స్ ఫ్రమ్ సివియర్ డిసడ్వాంటేజెస్. అయితే ఇవన్నీ కాదు ఇక మెదడులో గుర్తుపెట్టుకునేటి ఏంటి, పట్టుకునేటి ఏంటి, సంథింగ్ దట్ ఈస్ ఇన్హెరెంట్ టు మీ, మై ఐస్, my ears, my face, my fingerprint, biometrics. They are nowadays entity authentication procedures. All of our phones have this face recognition system, fingerprint recognition system, eye retina recognition system, ear scanner, ear recognition systems, voice recognition systems, signature recognition systems. There are now good entity authentication techniques. Of course, slowly but steadily, the cards and everything will become obsolete. Next generation bank cards. Do you know what happens to next generation bank cards? It is about to get launched. Maybe in the next few years, you will get a new ATM card from the bank. Nee card, inkokaru తీసుకెళ్ళి నీ పాస్వర్డ్ తెలిసినా సరే మనీ తీయలేరు. Before you insert the card into the ATM, there is a place on the card to put your thumb on it. ఆ ప్లేస్ లో థంబ్ పెట్టి కార్డ్ ఇన్సర్ట్ చేస్తేనే కార్డ్ వ్యాలిడేట్ అవుతుంది. వేరే వాళ్ళ థంబ్ దాని మీద పెట్టి కార్డ్ ఇన్సర్ట్ చేస్తే కార్డ్ లోపలికి పోతుంది, మళ్ళీ వెనక్కి రాదు. అంటే దట్స్ ఇట్, రైట్? సో ద థర్డ్ జనరేషన్ nowadays using something inherent entity authentication procedures, which is fingerprint, face recognition, all biometric procedures. I have just given you the explanation there. Passwords can be fixed, passwords can be one-time password. Passwords లో కూడా కాంప్లికేషన్స్ ఉన్నాయి. You get OTP. There can be a fixed password, there can be a one-time password. Fixed password suffers from eavesdropping. పక్కన వాళ్ళు వినొచ్చు, పక్కన వాళ్ళు దొంగతనం చేయొచ్చు, తెలుసుకోవచ్చు, ఏదో ఒకటి. There is a chance stealing a password, everything can happen. These problems can be solved by hashing a password. What is hashing a password? Or salting a password. There is another technique called salting a password. Salting a password is something like this. For example, say I have to log into my system. నా ల్యాప్టాప్ ఉంది నా ముందు. I have to enter. I have to log in and view my files. And there is a password prompt. I have to enter a password. So for example, when I first enter my password, for example, say my password is Sandeep, SANDEEP. That is the true password, okay? Then when I give a password, how will it identify that it is the right password? ఎట్లా దొరకబడుతుంది? మీకు డేటాబేస్ లో చెప్పండి ఒకసారి. ఇది అదే కరెక్ట్ పాస్వర్డ్ అని ఎట్లా దొరకబడుతుంది సిస్టమ్?
దీన్ని మళ్ళీ హ్యాష్ చేసి
హ్యాషింగ్ కంటే ముందు ఆ పాస్వర్డ్ ఫస్ట్ డేటాబేస్లో స్టోర్ అయి ఉంటుంది. సో వెన్ ఐ ఎంటర్ ఎ పాస్వర్డ్ అగైన్, దట్ పాస్వర్డ్ ఈస్ కంపేర్డ్ విత్ ది one that is stored in the database. If both of them are same, then you are allowed. If not, a wrong password, invalid password, try again. Then came up this hash technique, as Karthik was saying, the hash technique. The password that I enter first, well, when I'm setting a password, that password is put to a hash value, hash function. It generates a hash value, and the hash value is saved in the system. Why? Even if somebody steals from my system, వాడికి hash value దొరుకుతుంది, నా పాస్వర్డ్ దొరకదు. మరి ఎట్లా అథెంటికేట్ చేస్తుంది? హౌ ఈజ్ ఇట్ అథెంటికేటెడ్? వెన్ ఐ ఎంటర్ మై పాస్వర్డ్ ఫర్ ది సెకండ్ టైం, థర్డ్ టైం, re-entering my password again, when I log in again, the entered password is also put to the same hash function. The output is compared with the hash value that is stored in the database. If both of them are same, then you are allowed to log in. So ఎవరికన్నా వేరే వాళ్ళకి ఆ hash value దొరికినా సరే, it's of no use. Then there is salting. Salting is a procedure. Every one of our moms use this procedure, salting. What is salting? పచ్చడిలో ఉప్పు ఎక్కువ వేస్తారు తెలుసా? ఎందుకు? ఖరాబ్ బా సూపర్ అబ్బా, ఇది మాత్రం బాగా తెలుసు. ఎప్పుడైనా పచ్చడి పెట్టినా ఏంటి? రైట్, ఓకే, డన్, ఇట్స్ ఓకే. సో if a fixed length password is put to a hash value, a hacker can apply brute force attack. There is an attack called brute force attack, which you will study in the next semester. Brute force attack apply చేసి పాస్వర్డ్ ని క్రాక్ చేస్తారు. సో అసలు లెంత్ ఆఫ్ పాస్వర్డ్ తెలియకుండా చేయాలి ఫస్ట్ థింగ్. సో వాట్ హ్యాపన్స్ ఇస్ a technique called salting. Salting is take the actual password, add dummy bits to it, redundant bits to it, additional data to it, and then apply hashing on it, so that even if someone tries to know the number of characters in the password, it is not possible. Right? That's called hashing. Anyway, all this is simple password. Simple password suffers from lot of disadvantages. Then we can overcome this with the last line of my slide, OTP, one-time password. OTP removes the above problems, but it is a complex algorithm. It's not that simple. We cannot give an OTP to everyone for every time they log in. ఏదో బ్యాంకింగ్ ట్రాన్సాక్షన్స్ కి మనీ మేనేజ్మెంట్ అంటే చాలా అవసరం, చేద్దాం కాదనట్లే. బట్ ఫర్ ఎవ్రీ టైమ్ ఐ లాగ్ ఇన్ టు మై సిస్టమ్, మై ల్యాప్టాప్, జస్ట్ నా ఫైల్స్ చూసుకోవడానికి కూడా ఓటీపీ కావాలా నాకు? ఇట్ ఈస్ యూస్లెస్. ఇట్ బికమ్స్ కాంప్లెక్స్, రైట్. దెన్ దేర్ కెన్ బి అనదర్ టెక్నిక్ కాల్డ్ ఛాలెంజ్ రెస్పాన్స్. మన్మధుడు సినిమా మంచిగా గుర్తున్నదా? ఒకసారి చెప్పిన ఎగ్జాంపుల్, tehelka.com. Nagarjuna wants to buy that microphone from Dharmawar Subramaniam. There is a code, you remember? He goes to him and says, Akasham erraga undi. Then Dharmawar Subramaniam says, Akasham erraga undi. Then Nagarjuna has to reply with, Adi Deshadrahula Raktam valla vachindi. This is challenge response. There, that person, the comedian, Dharmawar Subramaniam, has posed a challenge to identify whether Nagarjuna is the person who talked to him on the phone or not. A challenge is posed and Nagarjuna has responded to that challenge. Then there is a synchronization. Acha nuva, namaste, shake hand. Then they exchange money and the object, right? So here it's the same thing again. Instead of using a password, why don't we use a challenge response, right? We are running out of time. I'll stop it with this. Now I'm not going to repeat these.